Alright, welcome back to part 3 of the Unity3D C# Prim's maze tutorial. So, first what we're going to do is, I've noticed, just for testing purposes, to make a new set of random numbers, we have to press play twice. There's actually a good way to do that in code. Now I'm going to rewrite update function back into this, and we have if Input.GetKeyDown keycode dot let's just say F1. So right here, this means if we press down the F1 key, then something happens, and we're going to have that something be load level 0. So it's going to reload this level. Oh, I'm sorry, key code has an uppercase C. Alright, so if we press F1, then the game starts over. So we can generate new numbers very quickly. This is just very good for testing purposes. Now something else you need to do is we're going to put in a public transform 2-dimensional called grid. Now, this is going to keep track of all of the objects in the grid, and it's going to do it in a 2-dimensional array. And the reason a 2-dimensional array is better than a list, or a 1-dimensional array in this case, is we can easily get to objects in the grid. Like, if we need to get to 0, 5, then we just go 0 and 5. If we want to get to 2, 2, we just put in 2 and 2. So it should be very easy and very intuitive, and that's what we want. So right now this is a null size grid, or null size array. So at the beginning of create grid, we're going to have grid equals new transform, and then size.x, size.z. So this is going to make the grid, or initialize the grid, with a maximum size of size x, size z. And we're going to assign each item in this array, like 0, 0, or 0, 0. And to do that, we do grid grid x, z. So in the first iteration, 0, 0 equals new cell. There we go. So this is public, but the editor in Unity cannot display 2-dimensional arrays. Okay, right here we have a cannot convert type float to int. That's because we're using a float here, size.x. Anything in a vector 3 is going to be a float. And to create array, or initialize arrays, they need to be integers. So they are integers, but they're well, they are floats, but in this case, size.x is going to be 5. We're just using vector 3 because it's just easier. So to change the float into an integer, we just do a explicit cast right here by typing open parentheses int end parentheses. Okay, so now if we go ahead and look, this error goes away, and unfortunately we can't see this grid variable, which is too bad, but that's okay. Anyway, what we're going to do now is we're going to add a script for this cell. So to do that, create a C# script called cell scripts. I'm going to add cell scripts to cell. Oh, missing mono behavior. That's from before when I was getting ready to create this video. And we're going to get some weird errors. Don't worry about that. Okay. So here we have cell script. Now we're going to have some variables for this cell script. We want a public list of transform, and we're going to call that adjacents. We also want a public vector 3, that's going to be the position. And now, no, this is the position in the grid, not the position in world coordinates. Like, it'll be whatever this is right here. 0, 1, 0, 2, etc. Position, and the last thing we need is weight. Now we're already assigning weight in the text, but since we're having a script for each of these, or a script for each cell, it's a good idea to have each cell know. So right here we're getting an error, type or namespace list cannot be found. Now the reason we're having that is because list, or to use a list, you have to include a package, so System.Collections.Generic. So you have to use System.Collections.Generic to create this public list, or to use lists in the script. So this should go away. It does. So let's assign position and weight really quickly. Right, so to assign position, it's just going to be the same as this basically. So I can copy this, and we'll have new cell get component cell script dot position equals vector3 x0z. So if we go ahead and run that, we have here 104. The position is 104. Okay. Now we should assign the weight. We're assigning weight right here with set numbers. So when we set the numbers, we're assigning the child.textmesh to the random number, but we should also assign this new thing that we have, the cell script, weight to weight. So this weight right here is the random number we made. We're going to assign the component's weight to that. So let's go ahead and press F1 a couple times, and let's see. This is probably easier to see in the editor. So right here, if we pick a random one, this has weight 2. Go ahead and look at the cell script. It has a weight of 2. This one's 7, 7. So it's going to match up every time. Now, this last thing that we have is adjacents. Here, let me look back up. It's going to be a list, and it has size 0. So what is adjacents? Well, adjacent means next to. And for Prim's algorithm to work, we need each of these cells to know what is next to them. So for instance, this 1 right here, it would have to know that right next to it is a 9, a 6, a 6, and a 2. And we're only going to be doing left, right, up, down, not diagonal. And so to find that out, we're going to be using a new function called setAdjacents. Okay, so we're going to be using a similar function, or not function, structure here, similar structure to the create grid, where we're going to use a double for loop. So void setAdjacents. It's going to be a double for loop. Let's say transform cell equals grid xc. And this is why we use, or we created this grid, this multidimensional array. So we can easily do cell equals grid xc. Now, we could also be using a for each loop, but I'm going to be using the counters x and z for this. Now, unfortunately, not all of these adjacents, or sorry, not all of these cells are going to have 4 adjacents, right? All the ones in the middle will, like this right here. This 2 has one right here at 4, 9, 8, and 1. But if you look in the corner, this cell right here is only going to have 2 adjacents. So first we have to make sure that an adjacent exists. So like to the left of this 9, there's not going to be one. So we figured that out because, or by doing some simple math. The position on this one is 0, 0, 0. So we know 0 is the smallest it can be, so we know there's not going to be anything to the left of it, right? So that might sound a little confusing, but let me show you a little more. So if actually here I'm going to have another variable called cscript, just so I can refer to the cell scripts easier. Equals cell.getComponents cell scripts. Oh, not cell scripts. Okay, it's cscript dot adjacent. No, cscript dot position. Actually, no, we don't even need to do that. If x minus 1 is greater or equal to than 0. So basically, if x is not equal to 0, if x is 1, then 1 minus 1 is greater than or equal to 0. If x is 2, it's greater than or equal to 0. But when x is 0, as in when it's the furthest to the left, then there's no way you can get, or well, if it's furthest to the left, then there's not going to be an adjacent there. But if it's not furthest to the left, then we can try to add the adjacent there. So then we do cscript dot adjacent, which is a list, dot add grid x minus 1 z. So this is going to add, okay, so let's take this one right here, 8. Its position is 2, 0, 0. Now we look to the left. Right here we have, there is something here. We're going to tell this right here, this cell, that it has an adjacent right here. And we're going to tell it what it is. So it's going to be this right here, x minus 1, z. So x is 2, z is 0, x minus 1 is going to be 1, and z is going to be the same, so it's going to be 1, 0. It's going to be this object right here. I'm sorry, this is a little confusing, but I'm not really sure how else to explain this. But if you go ahead and do this, you'll figure out what I mean pretty quickly. So go ahead and just follow along. Now we need to do the same thing for if it's furthest to the right. If it's furthest to the right, there's going to be nothing else to the right. So if x plus 1 is less than size x, size should be capitalized, then add this, x plus 1 z. We're going to do the same thing here for z. Now I should mention that there are other ways to do this. Like for my Minesweeper, it wasn't Minesweeper, it was for Cellular Automata, I think. I used a slightly different approach. Instead of looking in code like this with grid, I did a lot of raycasting for each, and that's an interesting way to go about it, but it uses too many other concepts that I don't really feel like introducing. It would just take too much time. So we're just going to be using this method right here. It works pretty well, and it's quite simple to understand, really. Once you can kind of see what all this means. So if we go ahead and look at this, it's probably easiest to see the result. Let's pick this middle one right here, 202. It has adjacents at 102, 302, 201, and 203. right? Whereas this one right here in the corner, it only has two adjacents, 1, 0, 0, and 0, 0, 1. So this is 1, 0, 0, this is 0, 0, 1. So those are the adjacents to it. Now, something we're going to need later is we're going to need to sort these adjacents. So let's go ahead and actually, yeah. Okay. Well, you know what? We don't need to write a separate script for sort adjacents. We can just have it in the set. So to sort the adjacents, what are we going to sort them by? That's what we need to know first. Well, Prim's algorithm is going to rely heavily on the weights, or these numbers. See, like this weight is 2, this weight is 4, or sorry, 2, 2, this weight is 4, this weight is 8, this weight is 6, etc. So to sort by the weights, we're going to need to write a custom iComparer. So first, let's see. Let's do for each. It's going to add up to 4 adjacents, and then we can sort them right here. So cscript.adjacents.sort, and we're going to be using a new function that we make up right here. It's going to be of type integer, and we'll have it be sort by lowest weight. Okay, and we're going to call that right here, sort by lowest weight. Now we're going to have it take in 2 arguments, because this is how sort works. So we can have transform, oops, this should be uppercase, transform A, transform B, actually we'll have it be input B, oh my gosh, input B, and input A. And I'll have the weights. So integer A, this is going to be A's weight, equals input A dot get component cell script dot weight. And same thing for B. We have input B dot get component cell script dot weight. Okay, so we have 2 variables here, A and B, and we're just going to use a simple compare-to function. So return A dot compare to B. Now, if I open up MScan here real quickly, go to the custom iComparer on MSDN, custom iComparer. This page will kind of explain what's going on if you want to read more about it. Oh, this is for arrays, but it's basically the same thing for lists. So anyway, I'll have a link to this page. Okay, so I'll have the link to this page. I'll actually put that in the comments here. So now this should sort the adjacents by each of the adjacents' weights. So let's see if that works. Did I save that? I did not. Okay. So go ahead and reload the scripts. Press F1. Now let's see. Okay, we have 0. So 6 should be first item in the list, and 9 should be the second. So let's see. 1, 0, 0 is this one right here, and 0, 0, 1 is this one right here. So yes, it is sorting correctly by lowest weight. let's just take this for instance, or maybe this one. 2, 3, 4, 8 should be the order, right? So 302 is right here. It's 2. This one right here is 201. It's right here. And 300 is right here. And 400 is this item. Oops. Oh, sorry, 401. I was going to say 401 is this one right here. Okay, so now we have each cell in the grid knowing what's around it and also what the lowest number around it is, or the lowest weight. Okay, so that's actually all we need to do for right now. I'm sorry part 3 has been so long, but it's a very complicated concept. If you can get this kind of stuff down, this is really useful later, especially these custom comparators using sort, and if you're doing stuff with grids that need to know, or that have cells that need to know what's around them, this is a perfect method. I've used this many times. Like I said, there are also other methods. You can use raycasting, but it's kind of complicated, and I feel like there's too many new topics that I have to introduce you to, including layers, as in sorry, layers, because if you're really using other things in the grid and you're using raycasting, you have to set certain layers so that you can be sure that you're raycasting only against certain objects in the game, and it doesn't hit other things like your player or your sun, or not sun, your directional light and stuff like that. So yeah, thank you for watching. This has been part 3